proteins monitor our genes. Damage to our DNA is continuously being repaired, and mistakes that occur during DNA replication are corrected. This year's Nobel Prize in Chemistry is being awarded to 3 scientists who have mapped these fundamental processes at the molecular level of detail. Thomas Lindahl's work succeeded in showing that spontaneous chemical processes cause thousands of potentially devastating damages to the genome of a cell every day. He concluded that there must be molecular systems that repair all these spontaneous damages, thereby opening the way to an entirely new field of research. Through his work, he was able to identify and characterize the repair mechanism that we know today as base excision repair. Paul Modrich studied how a cell can correct the base mismatches that sometimes occur during DNA copying. Through careful studies, he was able to identify and characterize the molecular machinery that is responsible for so-called mismatch repair. Today, we know that this system corrects 99.9% of all the errors that occur during replication of human genetic material. DNA can also be damaged by external factors, among them ultraviolet light and smoking. Damage that occurs in this way can be removed with the help of nucleotide excision repair. Our third laureate, Aziz Zanjar, has identified the components that build up this system and has explained in molecular detail how they work together to correct DNA damage.
Thomas Lindahl, Paul Modrich, and Aziz Zanjar. Your studies of DNA repair have revealed in finest molecular detail an amazing set of repair mechanisms that ensures the integrity of our genetic material. That is a truly great achievement. On behalf of the Royal Swedish Academy of Sciences, I wish to convey to you our warmest congratulations. May I now ask you to step forward and receive your Nobel Prizes from the hands of His Majesty the King.
Professor Emeritus Thomas Lindahl, born in 1938 in Stockholm, Sweden, is now affiliated with the Francis Crick Institute and Clare Hall Laboratory in the United Kingdom. He is here in Stockholm with his daughter and son, as well as his grandchild. Professor Paul Modrich was born in the US in 1946 and is a US citizen with Howard Hughes Medical Institute and Duke University School of Medicine. He's accompanied by his wife, Vickers Burdett, and a daughter. Professor Aziz Zanjar from Turkey is a Turkish and US citizen, affiliated with the University of North Carolina in the US. He's here in Stockholm with his wife, Esther Zanjar, family members, friends and colleagues. And now we will listen to The Maiden Under the Linden Tree by Wilhelm Pettersson Berger, the Swedish national romantic composer. Soloist is Daniel Johansson.
Oh
tenor Daniel Johansson, age 35. The Royal Stockholm Philharmonic Orchestra, and Anna Maria Helsing is the first female conductor ever to lead the orchestra at the Nobel Prize Awards ceremony. Now, time to listen to a speech by Professor Hans Forsberg.
Mina damer och herrar, runt omkring oss I naturen,
presenting the Medicine Prize.
pågår ständigt en maktkamp.
All around us in nature, in our skin and in our bodies, a constant power struggle is underway between myriads of microscopically small creatures that are fighting for their survival. Many are important constituents in nature's ecosystems, while others attack us humans and cause disease and death. This year's Nobel Prize in Physiology or Medicine is awarded to scientists who have enlisted the help of nature and made use of weapons from this power struggle in order to develop drugs against parasites that have plagued humankind since ancient times. Parasitic roundworms cause lymphatic filariasis and river blindness. These are lifelong diseases that have afflicted hundreds of millions of people in the poorest parts of the world. Satoshi Omura of Japan and William Campbell of the United States have made discoveries that have led to a drastic decline in these diseases and that will hopefully eradicate them within 10 years. It began with Satoshi Omura's search for natural substances that could be used in producing new drugs. He became an expert in culturing streptomyces, a type of soil bacteria known to produce antibiotic substances. He traveled around and collected thousands of soil samples from all over Japan, which he used for culturing bacteria. In one of Omura's bacteria cultures, which was sent to William Campbell's laboratory, a whole new strain of streptomyces was discovered, one that would change the world. In Campbell's laboratory, extracts from these cultures were given to mice that had been infected with roundworms. One of the extracts was remarkably effective, killing all the worms. Campbell purified the active component, which was given the name ivermectin. With the help of chemists, it was modified to become even more effective. The new substance was called ivermectin, and it turned out to have an extremely powerful effect on parasites in farm and domestic animals. Campbell now wanted to test whether this drug was equally effective in humans, and he helped start clinical studies on patients with river blindness.